In the solvent, you used angle properties to show that lines are parallel. In this lesson, you will apply the same properties to show that a quadrilateral is a parallelogram. In Lesson 6.2, you learned theorems about the properties of parallelograms. In this lesson, you will learn the converses of those theorems. That is, if a quadrilateral has certain properties, then it must be a parallelogram. Theorem 6.8, for example, is the converse of Theorem 6.3. Theorem 6.8 states, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, in the diagram, if segment AB is congruent to segment CD and segment BC is congruent to segment DA, then ABCD is a parallelogram. Theorems 6.9 and 6.10 are the converses of Theorems 6.4 and 6.5 respectively. They use angle relationships to conclude that a quadrilateral is a parallelogram. Theorem 6.9 states, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So if the measure of angle A plus the measure of angle B equals 180, and the measure of angle A plus the measure of angle D equals 180, then ABCD is a parallelogram. Theorem 6.10 states, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if angle A is congruent to angle C, and angle B is congruent to angle D, then quadrilateral ABCD is a parallelogram. You can use algebra together with theorems 6.8, 6.9, and 6.10 to find segment lengths and angle measures that assume that a quadrilateral is a parallelogram. Problem 1. Finding values for parallelograms. For what values of y must Pqrs be a parallelogram? We'll consider the diagram carefully. Step 1, we need to find the value of x. So 3x minus 5 equals 2x plus 1. Well, that's because if opposite sides are congruent, then the quadrilateral is a parallelogram. Solving this equation, we subtract 2x from each side and add 5 to each side to find that x equals 6. Now that we know x, we can solve for y. Y equals x plus 2. Again, that's because if opposite sides are congruent, then the quadrilateral is a parallelogram. Substitute 6 for x and find that y equals 8. For Pqrs to be a parallelogram, the value of y must be 8. Your turn. For what values of x and y must quadrilateral EFGH be a parallelogram?